Welcome back to the channel Shamina Sarfuddin, and here is another video of immunology. The video is going to concentrate on the precipitation reaction that occurs due to the antigen and antibody reactions. We all know immunologically many things happens because of interaction between the antigen and antibody. The antigen and the antibody are also used as diagnostic tools in the field of immunology. You know why? The antigen and antibody, they undergo many immunological reactions which are very specific in nature. For example, instantly if we know the amount of antibody, we can able to assess the unknown antigen and vice versa too. Now let's get into the unit, precipitation. Looking into the precipitation reactions. The precipitation reactions are mainly based on the interaction that which occur between the antigen and the antibody. Usually when the reaction occurs, it is mainly based on two soluble reactants that which come together to make an insoluble product which we generally call it as the precipitate. And these reactions mainly depends on the formation of lattices, which we call it as crosslinks, when the antigen and the antibody are said to extend in the optimal proportions. When there is an excess of either component, either in the antigen or in the antibody, it might reduce the lattice formation and the subsequent formation of precipitation too. The precipitation reactions differ from agglutination reactions mainly in the size, the solubility of the antigen, and the sensitivity. Antigens are soluble molecules which are larger in size in the precipitation reactions. And also, there are several precipitation methods which are applied in the clinical laboratory for diagnosis of various disease and disorders. This type of laboratory works can be performed in semi-solid media such as agar or non-gel support media such as cellulose acetate. So let's look into the definitions of precipitation. So there are many terminologies during the precipitation reactions, mainly precipitation, precipitin, precipitinogen, and lattice. Let us first look into what I mean by precipitation. When an insoluble reactant react with the product, that is your soluble antigen and the soluble antibody, when they fuse together or when they react together, there will be forming of clumps, or you can see a condensed material, which we call it as an aggregate, and this being separated from the solution separately, and those things we call it as precipitation. Precipitin, an antibody which is soluble that interacts with an antigen to cause with a precipitate. Let us see about precipitinogen, an antigen soluble that induces the formation of a specific precipitin, which we able to see it is a soluble activity antibody, and this is termed as precipitinogen. Looking at the lattice, it is actually a three-dimensional view where your single antigen may fuse with multiple antibodies, and thereby you can see a lattice being formed because of the several clumpings of the antigen and antibody complexes, and thereby leading to a reaction of precipitin. If the reactants, antigen and antibody both are soluble, then how could be the reaction can precipitate? And how could it can be detected? Looking at this question, we have an answer like when the precipitation actually developed because of the antigen and antibody reaction, that is, when the antigen must have at least two epitopes per molecule so that it can easily cross-links with the antibody and thereby it forms a lattice with a fusion of binding of antigen and antibody. For the lattice to be formed, the bivalent antibody will actually bind to the epitope on both the different antigens that are present with it. A second antibody molecule combined with the second epitope on one of the antigen molecule, and now comes the third epitope. And another antigen molecule now triggers to join to this complex again, and thereby it goes on the fourth antigen, fifth, like that. So when repeated several times, as I said, it goes on repeating with a new coming antigen being bind to the antibody. So the complex continues to grow. So until sufficiently larger it becomes to make it insoluble, and thereby no more antigens can bind to it. And this is the result of a precipitate. Because of this antigen is soluble, a number of molecules are required for lattice formation is thereby being confirmed. And this is why the reactant, that is the antigen and antibody, which are both are soluble, that should be the condition. Then how the reaction can precipitate. And it can be seen through our naked eye, that is the formation of lattice. So now we can look at, is there any effect on the precipitation? By changing the amount of antigen concentration. Let's look into that. When the antigen concentration is very low and the antibody is relatively high, for example, we can say the super abundant in nature, then the zone of antibody will become excess and thereby it leads to the formation of small complexes. If the mixture, say the reactant and the antigen of the antibody, are being centrifuged in the laboratory, the residual antibodies will remain in the supernatant. So after the centrifugation, you can see your supernatant getting collected on the top, right? So usually the precipitate settles down at the bottom. The supernatant usually contains the excess antibody which is not able to bind to the antigen. And that is why you say when the amount or the concentration differs between the antigen and antibody, this actually occurs. And this area, which we call it as a supernatant, they contain excess antibody. And this area where it contains the excess antibody is called as prozone. A more antigen is added. When a more antigen has been added, large aggregates are formed. When there is neither antigen nor the antibody in the supernatant. In such a situation, the supernatant that you have got is called as equivalence zone because all the antigen and antibody has interacted and therefore no one is there to be seen excess in the supernatant. And that's why the zone now it is called as equivalence zone. This where the maximal precipitation occurs, which increasing the amount of antigen, the lattice size becomes very small to precipitate. And in this situation, it is called as post zone. the zone of antigen being excess. So instead of reacting the platelets, the plateau, the curve comes back to zero. And that is why we see all three zones. One is prozone, equivalence zone, and the post zone. This is all because of the antigen and antibody reaction that which forms a precipitin. So looking into the types of precipitation reactions. There are several precipitation tests that have been observed in the laboratory system, all of which used in the clinical laboratory, and each and every system will be helpful for us to detect the antigen or the antibodies depending on the configuration of the assay. And moreover, each and every system of the precipitation reaction, they have different sources of error that must be taken into the account, which should have a particular laboratory procedure. In all the optimal lattice forms in the zone of equivalence, where the antigen zone and the antibody zone are said to be equal in nature. So it is based on two different concepts. One is passive diffusion and the other one is electrophoresis. Looking into the passive diffusion, they are more effective automatically without the need of voluntary reaction. Some could be sometimes one fluid, which can be a double diffusion method or capillary tube precipitation. Secondly, it can be gel. Based on that, we are performing the double diffusion or single diffusion radial immunoassay. Sometimes it might also be via electrophoresis. There will be a voluntary action because the proportion of electricity is being formed. So it could be rather countercurrent immunoelectrophoresis or immunoelectrophoresis, immunofixation electrophoresis, or it can be rocket immunoelectrophoresis. These are the types which describe about the types of precipitation reactions. And that's all about the precipitation and its types. In the next video, we'll be looking into the different types of precipitation reactions, the application and uses. Thank you all. Stay tuned to the channel Shamina Surfadin. And that's it about the precipitation types. See you all with another video in a detailed description about the types of precipitation reactions, its application, and its uses. Stay tuned to the channel Shamina Surfadin.